This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thank you for joining us on another edition of the Space Nuts podcast. Heard everywhere except my place because my wife doesn't understand astronomy. My name's Andrew Dunkley, and with me, as always, Professor Fred Watson, astronomer at large. Hello, Fred.
Hey, how are you doing, Andrew? Good to talk to you again.
And to you too.
Yeah.
Maybe the last time after what I just said about my wife. Now,
yeah, I was going to say you're. I wouldn't have touched that one myself, but
she's used to me now, I think. Now you're in Adelaide.
I am, that's right. I'm in Adelaide, South Australia, where I'm doing a couple of talks. I did a talk last night and one again tonight. So then back up to Sydney tomorrow.
Oh, busy time.
Yeah.
I've never been to Adelaide. I'm going to get there one day.
Oh, it's a lovely city. Yeah, you should
City
do.
of churches, isn't it?
That's what it's called, the City of Churches, but it's got a lot more besides that. And I've always found it a very pleasant place to visit.
And the people who talk funny.
They say they talk funny, but they all sound Aussie to me, so it doesn't make a difference.
Oh, dear. Now, today we're going to be talking about India's plan to land something on the moon and these new fast radio bursts that have been detected, but have certainly thrown up more questions than answers. Speaking of which, we're going to be talking about some questions that have come in about neutrinos, a near-Earth asteroid that's headed our way soon. And can we develop slow descent spacecraft by creating our own fuel in space? Interesting questions, Fred. We'll get to those soon. But let's talk about this plan by India to land on the moon possibly this weekend.
Well, that's right. Yes, and in fact, this is the planned landing date is 2 days from when we're recording this, so there's a good chance that
it will have happened by the time some people have heard
exactly that. Yes, so. You must forgive us if what we're saying now really doesn't make any sense by the time you get to listen to it. However, it's very exciting. I'm really looking forward to seeing how this mission pans out. So it is the Indian Chandrayaan-2 mission, which was launched, if I remember rightly, back on the 22nd of July, with a fairly leisurely transfer to the moon by the spacecraft, which is quite big. The Chandrayaan orbiter is a fairly sizable one because it carries on board a lander, which of course will land, and the lander itself carries on board a rover, which will rove once the landing has taken place. So the current status is that Chandrayaan, the orbiter, is indeed in orbit around the moon. that has all gone really successfully. I think great credit to the Indian Space Research Organisation, ISRO. They seem to have taken this project with a very high level of success, and all credit to them for that. But the crucial time, which the space agency is describing as the 15 minutes of terror, is when the lander actually drops down onto the lunar surface, hopefully safely. That is the part of a mission like this which is most critical. We kind of, we've got used to seeing successful landings on the moon from space agencies like NASA and Roscosmos, the Russian space agency, but it's still a process fraught with difficulty, because you've got to just judge exactly right the thrust needed to slow your spacecraft down so that when it touches the moon, it's not traveling at 2 meters per second or anything. 2 kilometers per second, but traveling at a matter of a few centimeters per second.
Well, there have been some famous miscalculations over the years where things have gone into the moon and into Mars or Venus or whatever at full tilt because of calculations that were the wrong way round, basically. But hopefully they won't run into any issues like this. We're certainly going with that 15 minutes of, or 7 minutes of, or 8 minutes of terror approach on a regular basis now, aren't we?
Yeah, that's right. I live with 24 hours of terror every day, but not for those reasons. So, assuming that by the time people listen to this, all will be well. The details are that the lander is called Vikram. It's named in honor of the person who founded the Indian space program, and that carries a rover whose name is Pragyan, a lovely Sanskrit name which means wisdom, which is something that's always sadly lacking on Space Nuts. But never mind, on the Indian spacecraft it will be there. And so the lander's got essentially sensors which will be actually detecting moonquakes. That's one of the things.
I was going to ask, what's the purpose of the mission?
Yeah, they're also, I like this very much, there's a NASA retroreflector on board as well. And you remember, these are the kinds of things that were left behind by Apollo astronauts, so that when you fire a laser at the moon, you get a direct reflection back and can do a time of flight measurement of the distance to the moon. So there is a laser reflector carried on board Vikram, the lander. And then the rover itself basically has got chemical analysis instruments on board, which will look at the minerals. And this actually is perhaps the really interesting part of this mission, is where they're locating the landing site, because it's very close to the moon's south pole, which of course is a bit at the top from our vantage point here in Australia. And it sort of in some ways mimics where the Chang'e spacecraft is, the Chinese one that's currently on the far side of the moon. Chang'e is on the far side. The Chandrayaan lander will be on the near side, but actually closer to the South Pole. It's going to be at about 70 degrees of south latitude, so very much in the moon's Antarctic, I beg your pardon, because it's the south. It's a very highland area. There are mountains and craters absolutely covering this area. So it's going to be a challenge to get the thing down on a site that's flat enough for it to stand upright and for the lander to work. But the chances seem to be good that will happen. But more especially, the reason why they're choosing this landing site on the near side is that perhaps the most interesting feature on the far side is something called the Aitken South Pole Basin, which is the biggest dent in the solar system pretty well. Comes about because of an asteroid impact very early in the moon's history. And that threw material out from basically from the moon's mantle, the layer underneath the crust. And it's thought that where the Indian lander will touch down is about where some of the most interesting minerals will have landed after that impact. So there might be stuff on the surface that really is samples of the moon's mantle. Really interesting, philosophy of the science to be extracted from this. And I wish them well.
Yes.
Hopefully all will go well, and we'll have some great results from the lunar surface.
And hence the reason for a rover, so you can get out and do that exploring and pick up your samples and do your analysis. And if you're relying on landing on one spot and just scraping something up, which is how they did it early on the Mars missions, you could miss a heck of a lot. But we've got better technology these days, so hopefully that will prevail, and we'll get some new information about the moon. How many countries have now landed on the moon? We've got the United States, we've got Russia, we've got China, we've got Israel, we've got India potentially.
Yeah, Israel, of course, the landing wasn't
really a landing, but
yeah, that's right. So
okay, how many countries have left debris on the moon?
So 3 basically so far, and
3.
hopefully 4 by Saturday. Yes,
Okay.
That's right.
We will watch with interest, and good luck to them. Hopefully it'll be a huge success. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to the topic of your discussion last night in Adelaide, in fact, 8 new fast radio bursts have been detected. These things are popping up from time to time, and as most things do in astronomy, they create more questions than answers. What do we know about these ones?
Not much, really. So
must have been a short talk.
Yeah, it was a short talk. Yeah, no, I did a lot of scene setting last night, and a lot of analysis of current Australian astronomy and how it benefits our studies of things like fast radio bursts. Okay, quick potted history of fast radio bursts. First one discovered, I think it was 2006, although it was reported in 2007 by Duncan Lorimer of West Virginia University, if I remember rightly, and his team. They found this single blip in archival data from the Parkes Radio Telescope. They're actually looking for pulsars, these rotating neutron stars, but they found just this blip of radio radiation, which was quite strong. And by analysing the details of it, something called the dispersion of the radio waves allowed them to realise that this was an object deep in space, probably, a billion light years away or something like that. And then there was a succession of these things discovered by the Arecibo radio dish in Puerto Rico. So the objects are characterized by the fact that over a period of just a handful of milliseconds, there's this bright radio flash, which, given the distance of these things, which are kind of known to be what we call cosmological, which means a long way away, that they are very, very energetic. They push out energy, which is kind of the same as the sun emits in a year, or something like that. Sorry, 10,000 times what the sun emits in a year.
Wow.
Let me get the facts right. They're huge amounts of energy, and very brief. And we still don't know what they are. But it was actually data from Arecibo, which I think in 2015 led to the discovery of the first repeating one of these, a radio burst, fast radio burst that actually repeats, not in a periodic way. It's quite a sporadic repetition. But the fact that it repeats means that you could, look at the spot in the sky where it comes from and see, you could basically determine where this object is in the sky fairly accurately, because it does it more than once. And then look at it with different sorts of telescopes, optical telescopes, that's visible light ones, infrared telescopes and things like that, and look at what's there. And it turns out that the repeater is in the sort of outskirts of a very ordinary dwarf galaxy at a distance of about 3 billion light years. Nothing really to tell you what is special about the environment in which this object exists. So, in terms of repeaters, that was the situation at the beginning of this year. There was only one repeater. It rejoiced in the name of FRB 121102 to give it its proper title. Then in January, a second repeater was found, and that got people very excited. Meanwhile, many of the single shot ones had been observed, and I think the total now is well over 100 of these single shot fast radio bursts. But as I said, in January this year, the sum total of repeaters was 2. But then within the last couple of weeks, we've had a report from a telescope, excuse me, Andrew, with a telescope with the wonderful name of CHIME. CHIME is the Canadian Hydrogen Intensity Mapping Experiment. And it's a radio dish in British Columbia, or actually a succession of not so much dishes as troughs. They're telescopes that are fixed in space, low-frequency telescopes. And they have turned up 8 repeaters.
Wow.
So that's put a whole new dimension on this study of fast radio bursts. It looks as though something like 10% of all known fast radio bursts are actually objects that repeat.
That creates a mystery in itself. I mean, trying to understand a single shot fast radio burst would probably be more logical because it was a single event. But to get repeaters, and this one being, what, an 8? 8 repeats? Is that what we're talking about?
No, I'm saying that there are 8 radio sources in the sky which are known to repeat.
Right. So that sort of makes the whole thing somewhat more complex.
It does, because you can sort of, you can imagine that, okay, if you've got one of these things, if you've got these things that just pop off, so single shot versions of the fast radio bursts, then you could account for that by some sort of cataclysmic event like the end of a star or something like that. But when they do it again and again and again, then that explanation doesn't hold up. And so, I mean, the theoretical work that's definitely going on in the background, trying to understand these things, is stuff that I'm not really very familiar with. But my colleagues in the fast radio burst trade, if I can put it that way, talk about flares on magnetars. Magnetars are very highly magnetized neutron stars, and apparently if they get flares on the surface, they can be very energetic.
Okay.
But I don't know, I'm not in a position to be able to judge whether that's a reasonable explanation. People have suggested colliding neutron stars as well, which we would perhaps be able to detect by gravitational waves, because we've seen evidence from gravitational waves of colliding neutron stars. So unfortunately, they don't sort of tally with fast radio bursts. But the mystery, I think, is still wide open, that we've got some of these things that repeat and some don't. The repeaters are in the minority, but they're not unique. That was the big news this year, and that's certainly what differentiates our present knowledge from what we would have been talking about this time last year, when there was only one repeater.
Yeah. I suppose we're also probably trapping ourselves in thinking, well, this must be caused by similarities in events, but maybe not. Maybe there's all sorts of different ways fast radio bursts can be created that we might need to think a bit more outside the box.
Exactly. Well, there is one person, excuse me again, there's one person who's doing that, and that is Avi Loeb of the Harvard Center for Astrophysics. You and I have spoken about Avi before, because he was very quick a couple of years ago to suggest that one possibility for such flashes in space might be people using radio lasers or something like that to propel light sails through the universe. It's basically an off-the-wall suggestion.
What, people other than us?
People other than us, that's right.
Oh, okay. That's interesting.
People of species and planets different from our own,
right,
whizzing light sails through the universe. I think that's a suggestion that most astronomers, they're slightly sceptical of, but nevertheless, it's a valid point, because he says that the physical parameters are consistent with what you get. But anyway, that remains to be seen. I have to say that Avi Loeb is very keen on the idea of solar sailing or light sail technology, because he's part of the breakthrough Starshot venture, which is looking at the possibility of sending a light sail to Proxima Centauri. And he was also, I think, very quick to point out that when Oumuamua flew through the inner solar system, yeah, that's right, the very same, that might be an alien spacecraft with a solar sail rather than just an asteroid. So you get a theme here, and he's very provocative. That's the best way you can put it.
Yeah. Oh, well, it certainly gets the attention of the media, and that's what it's all about.
Yeah,
sometimes.
That's right. Yeah, exactly.
Yeah. That's why I keep calling it the space doogie. I want all and sundry to pick that up.
They'll throw you out eventually.
It's not doing the rounds, unfortunately. All right. Well, more to learn, a lot more to learn about fast radio burst repeaters. We will hopefully solve that one in the not too distant future. This is Space Nuts. Andrew Dunkley here, and Professor Fred Watson there.
0G, and I feel fine.
Space Nuts.
Now, Fred, another shout out to our supporters on Patreon. The numbers keep climbing, and we're very appreciative that people are willing to sign up and just put a little bit of money in the kitty to support Space Nuts. It's a wonderful thing to do, and we really appreciate it. And if you would like to do the same, you can do that at patreon.com/spacenuts. There are different options there, and we're building up some benefits for our patrons, which will develop over time. I'm leaving that up to the production crew, but patreon.com/spacenuts if you're interested in signing up to support us with just a couple of dollars a month. And, of course, the Space Nuts podcast group, Fred, is growing at a rate of knots. They're numbering well over 100 now, and they're sort of talking to each other, showing each other photographs of their telescopes, and all sorts of things. It's really fantastic. So I'm so pleased that our podcast is bringing people together from all over the world. So if you would like to join the Space Nuts podcast group, it's on Facebook, and you just need to ask to join, and we'll sort it all out for you. Now, Fred, we are going to tackle a few questions. This one from Matt Geezer in Exeter in England, who says he's a very keen listener of the podcast. Hi, Matt. My question concerns the missing mass in the cosmos. Is it possible that neutrinos have a higher mass than currently predicted? If their mass was 2 or 3 times or more than currently predicted, it could account for much, but I doubt all, of the missing mass in the cosmos. Is it possible our current measurement of neutrino mass is incorrect to such a degree? Good question, Matt. Fred, what's the answer?
So I do recall some work. It's a few years ago now when I, hung out with cosmologists, because basically it's looking at the wider universe that actually gives an estimate of the mass of the neutrino. And I do recall a time when the idea of a massive neutrino was essentially written out of the equation by looking at things like the cosmic background radiation. This is what, the flash of the Big Bang, the way that the temperature variations in that are observed, and also just the large scale structure in the universe today. So it was something called the 2DF Galaxy Redshift Survey, which was published in the early 2000s. This is, it was at the time the biggest survey of galaxies out to a distance of about 2.5 billion light years, and it gives you this framework because what you see is the fact that the universe is a kind of honeycomb of galaxies arranged along the edges of the honeycomb, and it's that it sounds unlikely, but from that work you actually can deduce the mass of the neutrino, and I think it comes about because of it's something to do with the ratios between the number of neutrinos and the number of photons that are present. Certainly in the cosmic microwave background, that's the case. In the structure models that that basically we get from the redshift surveys, then you can interpret that in a similar way. And the bottom line is that the neutrinos do not have enough mass to contribute to the dark matter. They're a good candidate because they interact hardly at all with normal matter, but we can detect them. There are detectors such as IceCube at the South Pole that can pick up cosmic neutrinos. So it's the likelihood is that our estimate, at least our estimate of the upper limit of the mass of a neutrino, is very constrained, and it does not actually, it's nowhere near enough to count for the missing matter in the universe. A waffly answer to a very good question.
Bottom line is it's certainly not a miscalculation, and Matt's theory, well thought out, cannot be the answer to the unknown mass of the universe.
That is the bottom line.
That is the bottom line. All right.
Yes.
Thank you, Matt, for your question. Really appreciate it. Let's move on to a question from Gary Wilson, who is in Springwood up in the Blue Mountains of New South Wales. Beautiful, beautiful area. He said, "Hi, Fred and Andrew. Asteroid 2000 QW7 is passing Earth on September the 16th. Will we be able to see it with the naked eye from Sydney? And what time would it be passing closest to Earth? I guess we'll know if it hits us." This is yet another asteroid that all the reputable media outlets around the world have basically gone doomsday angle. It's not going to hit us.
It won't hit us, no, that's right. And I don't think this one will ever hit us because it's in an orbit that's locked in such a way that it whizzes past the Earth but doesn't actually, there's never a time when it's in the same place at the same time as the Earth, at least not for the foreseeable future, which in this sort of science goes several hundred years down the track. Its nearest approach is, I think, 5 million kilometres. And it's about it's something like up to 600 meters long.
It's a big one, isn't it?
Its size, it's quite big, but at 5 million kilometers, it's not going to be visible with the naked eye. I've just been trying to find the details, and they are pretty freely available on the web. I've got an absolute magnitude for it, which is not very helpful. That's basically the parameter which you use to measure the brightness of things. I don't even know whether it'll be visible in small telescopes. It's a long way away. Its approach to the Earth is, it's in the news and everything because it's such a big one.
Yeah.
But it is, in terms of visibility, I haven't really been able to get my...
Well, let's say for the sake of sensationalism, if a rock that big hit Earth, what would be the effect? 600 metres.
Yeah, it's significant. So you're talking about nationwide damage and devastation for something that size because of the energy that it imparts. Traveling, I think its approach is we've got 1,600 kilometers per hour. At that sort of speed, you're basically, an impact vaporizes the rock and causes shock waves and all the rest of it. So interesting stuff. And thank you for sensationalization. That's good.
Yes, indeed. Okay, so probably not visible with the naked eye or even a small telescope. So chances are, you're going to need some good gear to be able to spot this one, I'm afraid. But, that doesn't mean don't try, because you might be lucky. You never know. I wouldn't even know where to look, Fred, to be honest. I'd have to do some research.
Things like this move so quickly through the sky because they're relatively near. You need, very up-to-date, what are called finding charts. You've basically got to lock onto it. And it's a formidable thing to do. So I don't think many of us will see it. Okay.
And thank you, Gary, for the question. So let's move on to our final question for this week's episode from Duncan Sargent. Duncan's written to us a few times, I think. He's written another question more recently than this one, but we're trying to do some catching up. And thank you for the question, Duncan. If we manage to get a base on the moon or an asteroid or both and start using whatever is there to make propellant to refuel our spacecraft, does that mean we can do away with those tricky heat shields, as we will have enough fuel on board of a powered descent back to Earth, as we can fuel in space? And as such, will we be able to slow our spaceships right down and slowly lower them back to the ground rather than deorbiting in the way that we have to now? If not, why not? Good question.
It's a great question. So that's a really good point, and it kind of harps back to what we were just talking about with the Chandrayaan spacecraft, because that's exactly what it's going to do. It's going to use fuel and retro thrusters to bring it down. The problem is still that you need a lot of energy to do this slowdown, but okay, we've got a classic example of how this can work already, because, of course, Elon Musk is bringing his boosters down from orbital velocity to zero velocity using small amounts of fuel left in the spacecraft. So it suggests that the answer to Duncan's question is yes, that if we've got unlimited fuel, maybe we can dispense with the tricky heat shields. Because the Elon Musk boosters have already taken the spacecraft almost up to orbital velocity, and there's a small amount of aerobraking involved, but I think that's more about stabilizing the movement of the spacecraft. The real braking is done by the retro rockets. So I think Duncan's suggestion is a good one. And maybe in the future, we will see powered descents back to the surface of Earth, which, a lot is going to wind up depending on the economics. If it's more economical to have a heat shield and slow it down with aerobraking, well, that's what will happen. But it seems to me that the technology exists to do it now with retro rockets, and as Duncan says, to do away with the tricky heat shields.
Well, it might be safer too, I imagine. We've had some tragedies with heat shields in the past, and it would appear to me to be able to control descent rather than rely on just sort of whipping through the atmosphere at high speed with high levels of heat would be more desirable.
Yeah, although, yes, there were tragedies, but so if you think of the shuttle, and there was 130 shuttle missions, each of which, apart from the two that failed, each of which used the heat shield to slow the spacecraft down and return to Earth. It was very tricky. The two tragedies were not directly a result of the heat shield. They were caused by
other issues,
damage. That's right. So it's in many ways it's a fairly routine procedure, but to my mind, I kind of agree with Duncan. It's a lot neater and tidier to fire your retro rocket and bring it down that way.
I would, bring on, warp factor 1 and pulse. What do they call it? I can't remember now. Star Trek.
All of that stuff.
Terminology.
The only thing is, you wouldn't mind. So if you press the button to fire your retro rocket and nothing happened, you'd think, oh, I wish I had a heat shield.
Yes, that's a good point. That could be a pitfall, I imagine, and a definite fall. Not a very elegant one either.
No.
All right. Duncan, thanks for the question. The answer is yes, by the sound of it. That's where we're going to have to leave it this week. Thanks to everybody who's contributed and listened in and constantly peppering us with questions and talking to each other on our Facebook podcast group. It's fantastic. We've got quite a little astronomical community going now, Fred, which is a joy. And thank you as always. Travel safe home from Adelaide, and we will talk to you again next week.
It sounds very good. Thank you very much, Andrew, and I look forward to the next time.
A great pleasure. Professor Fred Watson, astronomer at large, joins us every week on Space Nuts, as do I and as do you. And hopefully we can catch up again next week on another edition of the podcast we like to call Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
Attention shoppers! BlendJet's Black Friday sale is on, and it's our biggest sale ever. Stock up for the holidays, because the more BlendJets you buy, the more you save. With over 50 colors and patterns to choose from, there's a BlendJet that's perfect for everyone on your list. Skip the mall madness. We've got you covered with fast, free shipping. What are you waiting for? Go to BlendJet.com and take advantage of our epic Black Friday sale. That's BlendJet.com.